How's it going? My name is Ed Meyer. I'm the program director for the Earth Sciences Off-Campus program, which is otherwise known as the Stretch. And I just wanted to start by telling you that the Stretch, I think, is a really unique opportunity to pursue experiential education. It's an opportunity to take many of the concepts that we talk about in undergraduate Earth Science courses on campus and to put them to practical use in the field. And there are really not too many other programs in the United States that do this with such breadth. So we cover a very large number of geoscience topics on our program, and I know of no other program that covers so much geography. So we start in Canada and we wind up at the Grand Canyon over the course of the fall term. So really, the program is a great opportunity to do science in the field for every day for almost 65 days straight. The program is offered every fall term, and it's a program that we recommend for our years and environmental earth science majors. And in fact, we strongly recommend it, but there are also many non-majors who apply and go on the program. So don't let your major status be a deterrent from actually applying. And I think one of the really unique aspects of our program is that it's broken up into a series of segments, and each segment is led by an individual faculty member or pair of faculty members. And so you get to meet lots of faculty in the department and to learn about their expertise. The program also allows you to interact with faculty in a much more informal manner than you would on campus. So you're living with these faculty in field research stations or in campsites, and you get to know about what motivated them to be a scientist, what their life is like as a faculty member. We also involve at least 6, but often more graduate students as teaching assistants on the program. So it's also an opportunity to get to interact with those grad students in a pretty informal fashion and to get to hear about what motivated them to pursue advanced degrees in the earth sciences, what the application process is like, et cetera. And I think that's also a really valuable experience. So I want to spend some time to give you a quick overview of the 7 different segments on the program, just to give you a flavor for what we cover. The first segment starts in Western Canada in Banff National Park, and it's a segment focused on how mountain glaciers are responding to climate change over the last couple million years, and in particular, how mountain glaciers are responding to anthropogenic climate change. So on this segment, you get to actually traverse the surface of the Athabasca Glacier. In some spots you get to rope up, and you get to do a number of studies that actually look at how this glacier is moving just over very short time scales, even the time scale that you're visiting the glacier for the week you're there, but also how it's responding to longer term climate change. From there, you head south across the US-Canada border, and you start the second segment of the stretch. And this segment is really focused on understanding Earth history through the lens of interpreting the rock record. So you spend some time just south of Glacier National Park looking at things like folds, faults, and sedimentary rocks, and thinking about what they tell us about the geologic history and evolution of the American West. And then you move to a place called the Bighorn Basin, which is about 80 miles east of Yellowstone. And there's spectacular exposures of rock seen here in the photo. I mean, just the best exposures of rock anywhere in the continental United States, or one of the best. And here you get to create geologic maps of these rocks. The rocks become your primary data, and you're out interpreting them and thinking about what they tell you about the geologic history of the Western United States. From there, we start another segment, which is in Montana, just outside of Yellowstone National Park. This is a high elevation alpine site, and it's the site of a couple hundred years of historic metal mining. So the focus of this segment is to think about economic geology, the formation and extraction of metal resources from the subsurface, a hot topic as we think about bringing more renewable alternative technologies online. So you get to create a geologic map, try to determine where a metal resource is, and then we spend time thinking about and looking at the environmental impacts of metals mining, especially in the context of it being so close to a national park and a World Heritage Site. From there, we move to another segment that focuses on understanding the geology of a number of what I would call the crown jewel national parks. So you're looking at Yellowstone, Tetons, Bryce, Arches, and Great Basin national parks. You're visiting these. You're doing short projects that help you understand surficial and groundwater processes and basic geologic processes that are occurring in these parks. From there, we do a long drive across Nevada and head over into California. So we're working our way south across the fall here, kind of racing winter south. And we wind up in the Eastern Sierra. And this is a pretty spectacular region of some of the highest or the highest mountains in continental United States. And the focus of this segment is to think about how these mountains record glaciation, and actually multiple glaciations over the last 2 million years. So we focus on creating surficial geologic maps of some valleys in these mountains. We're also thinking about some active volcanism that's going on in and around Mammoth, California. So it's kind of an interesting juxtaposition of ice, so glaciers, and modern volcanism. From there, we move a little further south in the Owens Valley, and we shift focus to a technological set of tools that are encapsulated under this term geophysics. So we're attempting to measure Earth's gravity and Earth's magnetic field to try to gain information about what's going on in the subsurface. And this is really cool. It's essentially a remote sensing technique to try to make inferences about phenomena that are happening in the subsurface. And then finally, we finish up the program in Southern California and Arizona region. So this is kind of the Mojave and Colorado Plateau region. And the focus shifts to using technology in the geosciences. So we start to integrate some satellite imagery, some iPads, GPS units, and software package called GIS software package to take data and to put it into digital formats so that we can interpret it in potentially more sophisticated ways. We also have a focus on this segment on planetary geology. So thinking about how processes on Earth might be analogs for processes that are going on other planets like Mars. I think one of the real unique aspects of our program, so that's the end of our program at the Grand Canyon. The last day, you actually get to hike down to the Colorado River. This is a photograph of the last day. And you go through a huge section of sedimentary and igneous and metamorphic rocks that tell a really spectacular story about the evolution of the American West. I think one of the unique things about our program is the real diversity of topics. So, it's everything from glaciology and climate change to Earth history to folding and faulting to volcanoes to processes that shape landforms to planetary geology and geophysics. It's a really incredible overview of the different disciplines and a very applied overview of the different disciplines or subdisciplines in the earth sciences. If you're interested in going on the program, here's my contact info. And the only thing that you need to do to go on the program is to successfully complete one of the EARS intro courses and to potentially take and to also take a summer term course called EARS 40 Materials of the Earth. So you just need one intro course and EARS 40, and then you're good to go for the stretch. The application deadline is February 1st. You can apply with the link shown here. Typically, we take about 20 to 25 students. In the last few years, we've been right at the 25 student limit. And the program typically runs from about the 5th of September to the 9th of November. You get 3 credits to go. And the program costs about as much as it does to be on campus for a term. There is financial aid available, and that aid helps defer costs of equipment needed to go on the program. It can also help defer costs of flying to and from the program, and then tuition and room and board fees. Aid is calculated for each student, so please contact me for information about that. And with that, I will stop the recording. Thank you.